How's it going, everyone? Vlad here with solosplc.com. In the last couple of lectures on Factory I/O, we've talked about conveyors, we've talked about detection using sensors, we've talked about values that we can display inside of our environment. Today, we're going to be working on a small challenge. So what I have in front of you is two conveyors and I have an emitter. Again, we've explained what that is in the previous lecture, so I highly encourage you, if you haven't looked at it already, to go and review that material. That being said, the challenge today, if I can play this sequence, is going to be to detect the size of the boxes. As you can see, I have one small one coming out, followed by a large one. So they are going to be randomized by the emitter, and they're going to be simply traveling on this conveyor belt. In a normal production environment, you can commonly see this in palletizing operation. So I've actually worked on a project where they merged a lot of the different production lines, and in that specific factory, it wasn't based on size, it was based on a QR code or the barcode of the product. That being said, here we can work on a challenge using the concepts we've learned, as well as some new instructions in Allen Bradley PLC Programming in order to detect the size of the box and detect which product that's going to be. And ultimately, that allows us to sort the boxes on one side or the other. But the goal today is going to be simply to count them and to display the counter on our panel, just like we've done in one of the previous lectures. Before we dive into the technical aspects, I want to ask this once again. If you enjoy this type of content, if you would like us to build this on a different platform, if you want us to cover any different hardware or software, make sure to leave us a comment, make sure to follow the YouTube channel, and we will be bringing you a lot more content when it comes to automation engineering. So the goal here is to discuss the application and how we would handle it in a real world scenario. And the first thing I would always do is look at the application. So just like I've done in the introduction side, I would play the real world scenario, or sort of discuss with, let's say, the operators, maybe with the people at the facility, what does this actually look like in person? And so just as I had pointed out, we have boxes of different sizes. Now you'll notice that the length of each box is exactly the same. Therefore, I can immediately tell that I cannot simply put two sensors that would detect the length of a box. What I can do though is I can position a prox reading from on top in order to read the width of the box. As you can see here, if I look at the conveyor, there's going to be a noticeable width difference of the two boxes, which is ultimately what the scenario is going to be about. Now, there's going to be several ways that you can solve any engineering problem. There's going to be thousands of ways that you can solve a lot of them. In this case, we're going to try and do our best to use the simplest approach. And so in my case, that's going to be to place a prox sensor, as I've said, that reads the side of the box to detect that the box is actually there, and then one that's going to be reading the top of the box in order to make sure that it is of one or the other width. So I'm going to use the same diffuse sensor that we've done in the past. I'm going to drag this out. Again, it doesn't matter if it's placed in the middle, at the end of the conveyor. It really is going to depend on the application. And I'm going to rotate the sensor. So again, in Factory I/O, you have three buttons. So the R is going to rotate along this axis, T is going to be this one, and then Y is going to be the one that we need. So now that I know that the box is in place, I need to identify what is the width of the box. And so I'm going to drag out a second sensor, position it next to the other one, and this is going to require some mechanical setup, but ultimately, as I've said, I want to read it from the top. So I'm going to go on the other side of the conveyor, and ultimately, in the real world scenario, this is going to be a mechanical engineering challenge with which I will let you deal with. That being said, what I'm trying to do here is I want to position the sensor higher up, first of all, and I want it to look at the box, because if it's positioned obviously as is, it's just going to stop the boxes. So in this case, I want to rotate this way. I also want to rotate, let's see here, this way. And then by using this red dial, you can adjust the vision of the sensor, so I can position it any way I would like. And so if you don't pay attention to the beam and the beam crosses the conveyor, if I play the scene, you'll notice that the sensor is immediately blocked, and essentially it's not going to detect any boxes or anything whatsoever because the conveyor is already in its sight. So this is something you need to pay attention to in the real world as well. So the length of the beam in this case matters. So I'm going to raise the sensor in order to be detecting the box. Now, the next thing I'm going to look at is how does the beam cross the box? And I can either look at it from this side, but ultimately what matters is, does my sensor trigger when the box is in place? So you'll notice that there is a point in time where the large box crosses both of my sensors, and there is a time where only the side sensor is going to detect the narrow box. So what I can create in logic is a way to detect just one type of box or the other. Before I can write the logic for this application, I obviously need to bring in the signals into my PLC, and so we need to read both sensors. We also need to actuate the conveyors. This is something I've already enabled in the logic, but we do need to make that happen. Remember, when I start and I stop on the control panel. So I'm going to click on File and select Drivers, just as we've done in the past. And let's take care of a couple of things. So first of all, we have both conveyors. So I have a 4-meter conveyor and I have a 2-meter conveyor. So those are going to be on my output 2 and output 3. So again, when the system starts via the push button, I want to enable those conveyors. And then I have a sensor 0 and sensor 1. So I'm going to position that under input 2 as well as input 3. And let's locate those tags and make sure that we have the right descriptions for those tags inside of our PLC program. Once we are in Studio 5000, I can select my controller scope tags. Remember that Factory IO is only going to read to the controller tags we've created, not the local or the program scope tags. So once again, we have 2 outputs and we have 2 inputs. So on the input side, I can immediately write the sensors. So this is a previous description that we had. So this is going to be, and we need to double check if we go back to Factory IO, if I look at the sensor, we have a label, and this is an exercise that you would do in the real plant environment. You need to figure out which sensor is going to which output so that you don't necessarily write logic that becomes or needs to be reconfigured down the road. So sensor 0 is the one that looks across the conveyor, and sensor 1 is that identifies the width of the box. So sensor 0, if we go back to our driver, is going to be the first input, so input number 2, and sensor number 1 is going to be input number 3. So we can call this a box detection photo eye. So this is box present photo eye, and that's going to be of state blocked. I'm going to put that in place, and then the next one is going to be box wide photo eye. And here, instead of, so this is going to be blocked, but ultimately this tells me that the box wide will block the photo eye, and the box that is narrow is not going to block it. The other thing that we need to figure out is the conveyors. So the conveyor side, we have 2 conveyors. So one is going to be on output 2 and the other one on output 3. So we're just going to keep it simple. We're going to enable both of them. So this is going to be output 2 and output number 3. So this is going to be a belt conveyor. So this is going to be belt conveyor 1 run, and the other one is going to be belt conveyor 2 run. Let's go into our logic. So Factory IO Sim, again, you can download the current version or any previous versions of the software on GitHub. And let's take a look at what we need to create. So remember that our system running is indicated by this green indicator, which is the output 0. So I can simply copy this, and I'm going to, actually it's already enabling one of our conveyors, so I can simply use the same rung. So I'm going to double click the rung, and here I'm going to create a branch. Let's see here, that's going to be right there. I'm going to drag it across this output, and I need to enable the second conveyor, which is going to be output 3. I'm going to compile this logic, and I'm going to immediately test it. Again, any change that you make, if you have the opportunity in the field to validate that what you have written is correct, is going to be beneficial. So once the PLC is done, I'm going to navigate into Factory IO. I'm going to simply press play. And in this case, you see that the conveyor is rolling. What I need to do is I need to press the stop push button. And you'll notice that both of the conveyors are stopped. If I press the start push button, both conveyors should start again. So that logic is definitely working. Now, before we write the logic for the sensors, one thing that we need to validate, and this is a very important topic in industrial automation, as you'll see in many applications, is that the sensors don't trigger at the same time. And what this creates is that when we detect a box present, we can't necessarily just read the second sensor because it will not give us the right status. And so what do I mean by that? Well, here you can very easily tell with the naked eye that this sensor is going to come on before sensor 0, and what this creates is a scenario in which you're not going to be able to easily detect in logic what the box looks like. And I want to demonstrate this in trends in Studio 5000 to drive another concept home. So let's switch in Studio 5000 and see what kind of trends we can create. I'm going to stop this animation for just a moment as we create the trends, and we can take a look at that. So to create a trend, we can navigate into our tags. We can also do it from the RSLogix interface. That being said, if I right click this, you will notice that there's a section called trend. So I'm going to trend this tag and it will immediately create a new trend. I do want to right click this and add a second trend pen as well. So I'm going to stop this animation. I'm going to right click my chart properties and I'm going to go into pens. Here I'm going to add and configure tags, and I need to add a second tag, which is going to be, once again, so Solos PLC underscore B underscore input underscore 3. And that's going to be right there. Perfect. We're going to press on add, press on OK. These are going to be two separate tags. So I want to navigate into my y-axis. I'm going to go into custom. And here, what I like to do for Booleans is I'm going to select this from -1 to 2 in order to give it enough essentially width up and down to demonstrate it. I'm also going to isolate graphing. So this is going to create a scenario where I have both of those tags on separate timelines. I'm going to not have any decimal places. I'm going to press on apply. I'm going to also look at the x-axis. And here maybe I want 30 seconds, I think is reasonable to drive the point home. I'm going to hit on apply. We can definitely play around with this. That's not a problem. I'm going to press on OK, and let's look at what this looks like in practice. Now, of course, it's going to be 0. I'm not currently running anything in factory IO, so I'm going to press play just like you would in the real world scenario. And let's look at the trend that we get for just a moment. And so you will notice that as these tags come up, remember the top trend is the sensor that is detecting the boxes. So this is always going to be consistent and is going to detect the box. The bottom one is going to detect a wide box. So this is only going to come on when the box is wide. And once we get enough of a trend, we can make a decision of what needs to be done in order to create the exact logic we're looking for. So I stopped the trend. I'm also going to stop factory IO's simulation so that we can start writing some basic logic, and then we're going to validate this in the real system. So I'm going to create a new rung in which I'm going to create all of my logic for this application. So I'm going to select new rung. Immediately, I want to put in a comment that will allow me to identify this part of the program by using the shortcut Control D. I'm going to say box sizing application logic in order to identify that everything comes after this rung is going to be related to what I am building in this specific case. And what do we need to do here? Well, we need to detect, first of all, the sensor number 1, which is detecting the presence of a box. And I can simply copy this because it was a counter that we used in a previous lecture and paste that in. So I no longer need this XIC, but I do need a one-shot. So one-shot is an instruction we've covered in the past on this channel, and it allows me to execute after that instruction for a single scan of my PLC, which is exactly what I want. I don't want to have any duplicates of my counters. So here I can drag out any instruction, and this is going to be a ONS or a one-shot. In this case, I'm going to create I typically create a series of one-shots. So I'm going to create Solus PLC underscore ONS. And this, let's say it's going to be 0. I'm going to right click, a new instruction. This is going to be bool 64. Just to have a lot of them, it's going to be a program scope tags. I don't need to read this in anywhere else. I'm going to press on create. Next, I need to identify the state of my second sensor in order to put that in the wide box or the narrow box counter. So here, what I'm going to identify is, as I've said, the on state, which is that the box is wide. And so I can simply copy this tag in. I'm going to change that to a 3 for the wide photo eye. And next, I need to create a counter for my wide boxes. We've created a counter in the past, and just like I would do in the real world, I would simply scroll up to that instruction, press on Control C, which is to copy. Alternatively, you can right click and copy instruction. I'm going to select the instruction below, press on Control V, and I'm going to change this. So this is going to be wide box counter. So I'm going to create a different one. So wide box CTU, press on Enter, right click, new white box CTU, type counter. This is going to be inside of tutorials. That's perfectly fine. I'm going to reset that back to 0. And then I still need to detect whether or not I'm getting a narrow box. So for the narrow box, I'm going to simply branch out. I'm going to branch around this. And if the photo eye is not blocked, so this is going to be XIO, so not blocked, this is going to be a different counter. So I'm going to say, actually, I mislabeled this. So wide box CTU, new white box, press on create. And this is going to be narrow box CTU. I'm going to create that as well. Everything looks good. Press on create. We have our logic in place. It is time to test once again. So I'm going to finalize this. Both of the counters have been initialized to 0. So we're going to be, actually, I'm going to reinitialize this one. We're going to look at our application and we're going to observe the boxes passing through in order to identify the number of real boxes and then confirm that the logic is working as expected. So all I'm going to do here is I'm going to play the animation and I'm going to count the number of wide and the number of narrow boxes. So at this point we are at 0, 0. So this is going to be 1, 0, 2, 0. Again, the program is randomized. This is going to be 2, 1. This is going to be 2, 2. This is going to be 3, 2. And for the last one, we are going to be at 3, 3. So I'm going to stop the animation there. I'm going to go back into my Studio 5000. It looks like I stopped it a little bit prematurely, so it didn't pick up one of the white boxes. It could also be a problem in my logic, a problem in how I am detecting these counts. That being said, it seems to be fairly reliable. Obviously, there's going to be some tweaking maybe on the mechanical side in the real world to make sure that we pick up at those counters, but we are getting the counts inside of our Studio 5000 environment. I want to display them on my panel. So I will save you a little bit of time. What I've done is I've created 2 counters, one for wide box and one for narrow box. We've covered this topic in one of the previous lectures. So I'm going to navigate into Studio 5000 and set up the logic and show you what needs to happen. So in this case, I have 2 integers, as I've said, one for wide boxes, one for narrow boxes. I can go back to my sim, and here I can create the logic just like we've done in the past using this move instruction. I'm going to paste this in, and remember that we need to get the wide box counter. So wide box counter underscore CTU dot accumulated. I need to get that into my Solus PLC integer output 1, and I need to get the narrow box counter. So this I'm going to change to narrow accumulated to output number 2. I can validate or press to confirm this logic, go back into my environment of factory IO in order to look at the counters. So let's go back into the scene. I can press play, and you'll notice that I positioned the 2 counters at the bottom here so we can see exactly what kind of boxes are coming through. And you'll notice that the increments are working as expected. This becomes a lot easier to troubleshoot. You have smaller boxes, you have wider boxes that are coming in. and we can see the counters increment. And it seems to be fairly reliable. As I said in the previous one that we've played and I didn't get the 3-3 count, it's probably because I stopped it a little bit earlier. That being said, the signals seem to be working okay. You'll notice that that box, it actually didn't pick up as expected. And I'm assuming that we can go back to the trends, we can tweak the way these sensors are positioned in order to get the most reliable trend. That being said, we have accomplished the task, I would say, fairly reliably. And so if you want to play with this animation, if you want to work on this, again, you can download the source code on GitHub. You can tweak it in any way you would like. And if you have any suggestions for the following topics, make sure to leave them in the comments.